A muddy perimeter outside Anzio, April 1944. An American engineer presses flat against a shattered stone wall and watches something crawl out of the haze on the German side of the line. It is low, boxy, barely higher than a man's knee, dragging a thin black wire behind it like a leash. For a moment, nobody fires. It looks less like a weapon than a child's toy that wandered onto a battlefield by mistake. Then someone further down the line remembers the briefing about German remote demolition carriers, and 3 rifles open up on the wire before the little machine has covered half the distance to the wall. That machine is the Goliath, and it was never meant to carry a man into battle. It was meant to let a man stay alive somewhere behind the front, working a small box with a lever, while a miniature tracked vehicle he could barely see did the dying in his place. German combat engineers had learned a brutal lesson in the opening years of the war. Clearing barbed wire, minefields, and bunkers under fire meant sending sappers forward on foot with satchel charges, and those men died in appalling numbers doing a job that had nothing to do with skill and everything to do with exposure. Late in 1940, German ordnance officers recovered an abandoned French prototype near the Seine, a small experimental tracked device designed before the war by the engineer Adolphe Caigres to deliver an explosive charge without a crew. It was crude and unfinished, but the idea underneath it was exactly what German planners needed. They handed the concept to the Bremen automobile firm Borgward and told the company to build something that could carry a heavy explosive charge into a fixed position and detonate it, all without risking a single German soldier at the point of impact. Borgward's engineers built the first production version around 2 small electric motors, wiring the whole vehicle to a control box through a long cable spooled out behind it as it advanced. That version, designated SDK-FZ302, could carry roughly 60 kilograms of explosive and crawl forward at about 6 kilometers per hour, slower than a man walking briskly, but low enough to the ground and small enough in profile that it could, in theory, slip under machine gun fire aimed at a standing target. The electric motors were quiet and gave an operator smooth control over steering in both directions, but the batteries were heavy, expensive, and limited the vehicle's practical range to well under a kilometer. Borgward's follow-up version swapped the electric motors for a small 2-stroke petrol engine, trading some of that smoothness for a dramatic increase in range, and a later, larger petrol variant pushed the explosive payload up toward 100 kilograms. Every version answered to the same joystick control box, connected by a triple-strand cable that could run out to roughly 650 meters. 2 strands carrying steering commands and the third reserved for the single final command that mattered most: detonation. Each unit cost the German war economy something in the neighborhood of 3,000 Reichsmarks to build, and by the time production wound down, German factories had turned out more than 7,500 of them. On paper, the design looked clever. In practice, its low, boxy hull sat barely above the ground, which meant a rut, a fallen branch, or a churned-up patch of mud could stop it dead well short of any target. And that same low profile did nothing to protect the thin steel skin around its explosive charge from an ordinary rifle bullet. If you're enjoying this, a subscribe helps. Now back to a machine that looked far stranger in the field than it ever did on a factory drawing board. Goliaths reached frontline units on every major German front by early 1942, used against minefields, wire obstacles, and fortified positions on the Eastern Front as German engineers tried to clear paths ahead of advancing armor. During the enormous tank battles around Kursk in the summer of 1943, engineer units pushed small numbers of them ahead of assault groups to blow lanes through Soviet minefields before infantry and armor followed, with mixed results depending on how quickly Soviet gunners spotted the trailing cable and cut it. Roughly a year after Kursk, American and British troops met the machine directly on their own fronts for the first time. At Anzio in April of 1944, small numbers of Goliaths crawled toward Allied positions along the stalemated beachhead, and by June, more appeared among the beach obstacles the Wehrmacht had spent months preparing against an invasion everyone on the German side knew was coming. On the Normandy beaches, naval gunfire and artillery barrages severed control cables before most of the machines had traveled more than a few meters, leaving them sitting uselessly in the sand while the actual battle moved past them entirely. Soldiers who stumbled onto an intact, undetonated Goliath in the weeks after the landings often did not even recognize what they were looking at, and more than one abandoned unit ended up photographed by curious troops posing beside it like a captured piece of enemy novelty, rather than a weapon that had been built to kill them. That same summer, German garrisons even turned a handful of Goliaths against the Warsaw Uprising, sending them into streets held by Polish resistance fighters who, like soldiers on every other front the machine reached, quickly learned that severing a thin black wire was usually enough to stop one cold. Set next to what Allied engineers were doing to solve the exact same problem, the contrast is stark. Rather than sending an expendable unmanned box into a minefield or a wire obstacle, British engineers under Major General Percy Hobart had spent the same years developing specialized armored vehicles built on the Churchill tank chassis. Heavily protected machines that carried a full crew and purpose-built demolition charges directly up to a fortified position under armor, rather than under remote control. Those vehicles, later nicknamed Hobart's Funnies by the men who used them, could absorb hits that would have severed a Goliath's cable in an instant, and a trained crew inside could adapt to a changing battlefield in a way no operator watching a distant cable-linked box ever could. The German approach traded crew safety for a fragile, single-use machine with a breakable lifeline. The Allied approach spent more steel and more armor to keep men alive inside a vehicle that could actually fight back, reload, and improvise when a plan went wrong halfway across a beach or a minefield. A Churchill-based demolition vehicle that took a hit could often still complete its mission with a shaken but living crew inside it. A Goliath that took the same hit was simply gone, its charge sitting inert in the open until someone walked out to either detonate it by hand or drag it away as a curiosity. Given how often German cables were cut before a Goliath ever reached its target, the Allied trade proved the more effective one on most of the battlefields where the two approaches collided. A common myth about the Goliath imagines it as an early radio-controlled robot, guided invisibly the way a modern drone might be. The reality was far more physically constrained. Every Goliath ever built trailed a literal wire behind it, unspooling from a drum as the machine advanced, and that wire was both its only connection to a human operator and its single greatest weakness. A rifle round, a shell fragment, or even a determined soldier with a knife could sever the cable and turn an armed, explosive-laden machine into an inert box sitting in the open, which is precisely what happened to a large share of the Goliaths that Allied troops ever encountered. What the Goliath left behind mattered more than what it accomplished in its own time. Military historians and robotics researchers now point to it as one of the direct conceptual ancestors of the remote-controlled and robotic vehicles used today to disarm roadside bombs and investigate dangerous spaces without risking a human operator. The core idea? A small, tracked machine doing a deadly job at a safe distance from the person controlling it turned out to be sound, even though the 1940s technology wrapped around that idea was fragile, slow, and easy to defeat. Decades later, bomb disposal teams walking modern battlefields with tracked robots trailing their own control cables and cameras are, in a very real sense, still refining a concept a Bremen car company sketched out for the Wehrmacht. Surviving examples now sit in tank and ordnance museums in Britain and the United States, studied less for what they destroyed in combat than for the uncomfortable fact that the basic concept behind them never actually went away. Back outside Anzio, the wire goes slack in the mud, and the little machine stops moving well short of the wall. The American engineer waits a long moment before he moves again, still not entirely sure what he just watched crawl toward him. Somewhere behind the German line, an operator lets go of a lever that no longer controls anything at all. What Borgward's engineers built was never meant to look impressive, and on that count, they succeeded completely. It was meant to carry death forward on its own while a man stayed safely out of reach, and against the wire cutters, the artillery, and the sheer bad luck of Allied fire, the promise behind that idea broke down again and again in the mud of every front it was sent to.